Good afternoon. So I'm John Behrens. As I said earlier, I'm a professor of the practice of technology and digital studies and a concurrent professor of the practice of computer science and engineering here at Notre Dame. I'm also the director of digital strategy in the College of Arts and Letters. I'm also, most importantly, the moderator for our next panel, which is entitled Challenges and Concerns of AI in Education. Obviously, we've heard challenges and concerns and opportunities throughout the day, which we appreciate. But at this session, we'll have a little bit special focus on that as well. I'd like to suggest that you read the biographies of our panelists who are all distinguished and highly achieving. I don't know how any of them get any sleep. But let me just give a quick overview of our panelists. Our first panelist will be Ken Kadinger from the Human Computer Interaction and Psychology Department at Carnegie Mellon University. Ken directs Learn Lab at CMU and was the co-founder of Carnegie Learning. Wayne Holmes, on my left, is associate professor at the Institute of Education at the University College London. Wayne is leading the Council of Europe's AI and Ed project, which is developing a legal instrument for the use of AI in education. Yurin Chen, at my far left, is the John Koch Distinguished Professor of Electrical and Computer Engineering at Duke University and is the director of the NSF AI Institute for Edge Computing, leveraging next generation networks. We've got a lot of brains going on here. Ken, are you ready to present? Do you hear and see, and we're all good to go?
Yeah, yes, I hear and see, and I can share my screen and get rolling.
So, Ken Kadinger, thank you.
Sharing here, clicking slideshow. Hope you can see it. Yes. Can you see my slides? Just confirming. Yeah. Okay. Great. So I will talk about challenges and opportunities for AI in teaching and learning. Clearly AI is a hot topic, especially with the emergence of ChatGPT about a year ago. One key message I want to make, though, is that AI in education didn't emerge a year ago. It's a 40+ year history. And to put those two together, I thought I would ask ChatGPT to write a 2-paragraph summary of the 40+ years of AI in education research, starting with the 1982 book on intelligent tutoring systems. So you know how it goes. When you go to ChatGPT, I was using 3.5, as you can see here. You enter a query like this, and boom, it starts writing like that. And 6 seconds later, I have a 2-paragraph reply. So what did ChatGPT say? Well, first of all, it sounds smart. That's one thing we know. And I think this is risky because sometimes it sounds smarter than it is. For example, it says this book was authored by R.M. Gagne and colleagues. They produced a chapter, but they were not the editors of this book. So, it gets things wrong. But in this case, it does a pretty good job. It mostly gets it right. Intelligent tutoring systems utilized AI to provide personalized and adaptive instruction to students. They proved to be effective tools for enhancing learning outcomes, and they did so by tailoring content and feedback to individual student needs. And it cites work of ours in creating this cognitive tutor work that we spun off in Cognitive Tutor. I did not ask it to do that, but I can't complain that it did. It highlights emergent research areas like adaptive learning platforms, educational data mining, and learning analytics. It also goes on and highlights the particular enabling technologies: machine learning, natural language processing, computer vision. The first two are part of what's most apparent in ChatGPT, but I want to highlight how computer vision is also quite relevant for AI in education. I'll give you a nice video demonstration of that later. It notes influence on practice. Widespread adoption of online learning platforms has accelerated the integration of AI. Those cognitive tutors it mentioned we got in schools in the 1990s. They were really the first ITSs to be at scale in schools. But it also cites ongoing challenges, privacy, ethical considerations, and the digital divide. And I'm sure you're going to hear more about those challenges from Wayne. But to me, the overarching challenge is the risk that education will fail to benefit from AI because we get too caught up in the technology wow factor. And that, there's a lot of excitement and racing to create these, chat-based intelligent tutoring systems like Khan Amigo, which may end up being wonderful, but we can't just declare it's wonderful because it looks cool. We need to be sure we don't ignore the lessons learned from 40 years of AI in education research. And one of those lessons is that it can't just be computer scientists. It's really an interdisciplinary operation. If we do not do interdisciplinary research, we're not going to produce these benefits. And that means we need collaborations with researchers, not just in computer science and AI, but psychology, education, design, multiple disciplines, and instructors in the content domains. So just to give you a little sense of what some of the opportunities are, here's a very old screenshot of from the cognitive tutors we developed. This was from a unit on linear equation solving, systems of linear equation solving in our algebra course. Some problems are more focused. This is a multi-step, almost mini project where they're analyzing 2 cell phone plans using a table and a graph, and not shown, but equation solving. So the intelligent tutor can track students as they're working on authentic problems. Here, filling in this spreadsheet, and they're writing the expression for the current plan, as opposed to the new plan you might switch to. And they've made an error for getting the 1495 intercept, and the intelligent tutor captures that and gives them feedback. They're later asked, the culminating challenging question is, when do these 2 plans cross over? And they, they're further along in this spreadsheet. But, at any point in this process, this is active learning. If students need instruction, they can get it by pushing the hint button. And this says, well, take your 2 formulas and set them equal and in the equation solving tool and solve that. And they can get more specific instruction if they need it, or go on and do it. If students do struggle, that it's captured in the model such that they'll get more help on that topic later. If they succeed, they move on to things that they need to learn. So there's 2 layers of adaptivity here that are quite powerful. And have proven to be effective. These cognitive tutors for math have been widely used for 25 plus years, serving 500,000 students per year, really substantially, up to 80 minutes per week, and have been demonstrated in very large scale randomized field trials. The one I'm displaying from the RAND Corporation in 2013 was 140 schools, 70 of which were randomly assigned to make use of the full curriculum that we developed, including the intelligent tutoring system, textbook materials, and professional development, compared to the other 70 schools who kept using their traditional curriculum. And a lot of deep, detailed analyses, but the upshot is that the growth over the year for the 70 students using cognitive tutoring algebra was double that of the traditional course. But AI and ed research hasn't just contributed to practice, it's contributed to educational research. We published a paper in the Proceedings of the National Academy of Sciences earlier this year, where we took data from AI-based tutors like the one I just showed you, but also ones at earlier elementary math, college level statistics, some language domains. It was 27 different data sets. I'm illustrating just 4 of them here. We built growth curve models, or learning curve models, where opportunities to practice here on the x-axis. And we have a log odds transformed learning curve here for each student. And what was striking about this is how parallel these lines are. There's an astonishing regularity in student learning rate that I was very surprised to find in these data sets. At the same time, striking differences in the starting points for students who are all supposed to be meeting the prerequisites of the courses that they were using these in. These were all embedded in courses, right? So these students are ending up in different places, but not because they're learning at different rates, but because they're starting off at different places. And I think there's a lot of important equity-related messages in that. And AI and Ed is more than chat, just GPT. I mentioned this earlier. Here's an application where kids are learning science by doing science, where they're guided by an AI agent on screen here. This is a Kinect camera, and inside is an AI vision algorithm that is watching students as they run experiments on balance on this shaking earthquake table. And if I can show a quick video of this, it could give you a sense for how engaging this is and how thought-provoking it is for these young kids to actually do science.
These black blocks, if they have these on both sides and it has this on the top, so I think, yeah.
Made a prediction.
Uh-oh, your prediction was not.
The AI recognized the prediction was wrong.
Why do you need the star file first? Because it is taller, because it has a thinner base, because it has more weight on top.
They're asked to explain what happened. So predict, observe, explain. Later, they do engineering tasks. They're building their own towers. So he learned about bigger base and now he's applying it. I don't want to stop playing. I'm going to be a builder when I'm going to grow up. A lot of these don't fall. Here's classroom use of it. It's in about 30 sites, some museums as well as some classrooms and learning centers.
Is this the way that you learn with your teacher in the classroom, or is this different? You never do this?
It's extremely funner than school.
Extremely funner than school. Hard to beat that one. There's a lot of great research that Nezra Yanir has done on this. One of my longtime colleagues. I don't have time to go into the details of this, but there are multiple studies showing that when you turn the AI off, you don't get anywhere near as powerful learning, and students aren't as engaged when they don't have the interaction that the AI provides. That's not shown here. But what's also cool is if you just have them practice building towers, that's this condition here. They don't get anywhere near as good at building towers than if you have them actually engage in guided scientific discovery first, or a combination of the two. So it's not just about hands-on, it's about structuring a guided inquiry activity and getting immediate feedback. So my last example is about how AI and Ed can support teaching. So here, this experiment, teachers were given smart glasses where they could see struggle icons over students in their class who are working with the cognitive tutor. So these icons indicate that a student might be looking like they're engaged because they're clicking away, but they're actually gaming the system. Or another student's making lots of errors and not seeming to make progress, unproductively struggling. Others might be productively struggling. Some might be idle. The teacher can then walk over to the student who's demonstrating a need for help, not just students who are raising their hands. And the important thing about that was really powerful result is that those with those glasses on, those teachers with those glasses on, are shifting their attention to the students who need it most, the low pretest students, way more than in two different control conditions. And the learning outcome differences are incredible. The pre-post gain for students in those classrooms was 3 times bigger when the teachers had those glasses directing them to the students that really needed the most help. So AI and education opportunities, it contributes to practice and research. It's more than ChatGPT. It can help teachers in teaching. There are definitely challenges in privacy, ethics, digital divide, and educational equity. But I also think there's this overarching challenge that we don't want to get caught up in just in the wow factor of the technology. We have to learn from the lessons of lots of research in this interdisciplinary field of AI and education. And we need to continue in academia and in the ed tech industry to have collaborative teams, not just AI folks coming in and saying this is how it's going to work, but bringing in expertise from all these areas. That's it. Thank you very much.
Thank you very much, Ken. Our next speaker is Wayne Holmes. Wayne? I think you just press this. Thank you. And we're 2 minutes ahead, so cool.
Okay, well, I want to start by thanking Alison for inviting me here today. But after hearing what's been said all day, I feel like I'm a little bit in the Shark Tank, the academic Shark Tank, because the things I'm going to say might not be so popular as a lot of what we've heard already today. So to begin with then, a lot of what I say, people might think I'm being a little bit negative. But I like to think that I give a critical but constructive approach. That's for you to decide. But nevertheless, people do think I'm a bit negative, but I see myself in this David and Goliath position where it's me versus an awful lot of big, well-funded companies. So I'm gonna give my voice, and I probably should add things like Khan Academy on this, but I didn't do it in time. So that's where I'm at. So what I want to do first of all is talk a little bit about artificial intelligence, which is something a lot of you know about, but you might not have heard this particular perspective. So we know that it's around a long time. We know it's doing some amazing things. You know, a bunch of this stuff here I think is incredible. I think one of the most powerful and useful uses of AI is the picture in the bottom left there, which I think is superb. And I'm just pretty sad it's an AI picture and not a real picture. But let's try and burst this bubble just a little bit. Let's try and think this through. So AI has multiple limits. Now, when I show you this picture, what do you see? Thank you. And the AI system agrees with 57.7% confidence. That's pretty good, yeah? So what happens when we mix this picture of the panda in with this visual noise? Okay, well, this is what we end up with. And what do you see? Humans in the room, what do you see? You see a panda, a noisy panda. Okay. This time the AI is even more confident, which I think is impressive. Unfortunately, it's pretty confident it's a gibbon. So AI is pretty brittle. Here's another way of thinking about it. So this is a cartoon for sure, but it's quite true. So there's the mummy training the AI system, saying there's daddy. So the baby replies, there's daddy. There's daddy. And there's anyway. AI systems are not very strong at times. They can be very brittle. So this is a study from China a few years ago. And there are lots of stuff that's good that comes out of China, but this was quite impressive. And this was about using facial recognition to determine who are the criminals and who are the non-criminals. Well, if you look at this very carefully, it's very obvious. If you do not want to be detected as a criminal, wear a white shirt. Because that's all this system was identifying, who was wearing a white shirt. Here's another one. If you are like me, the AI system is pretty good at identifying me. If you are a man with darker skin tone, not quite so good. If you're a woman with lighter skin tone, less good. If you are a woman with darker skin tone, really quite bad. Now, admittedly, this was a little while ago, but things have not changed a great deal. Who's this? The AI disagrees. This young woman, she wanted to put her profile on LinkedIn, and she wanted to improve her photograph. So this is how the AI system improved her photograph. Okay, so AI is pretty brittle, and we mustn't put quite the trust in it that we do. Another thing that we often hear is that the AI systems do stuff on their own. AI systems learn. AI systems do this. AI systems do that. AI systems do not function without people. So a human sets the objectives. A human chooses and cleans the data. A human labels the data. This is a picture from a company in Kenya. And those people, they spend all day long looking at video frame after video frame after video, identifying that's a car, that's a person, that's a car. Next frame, that's a car, that's a person, that's a car. Next frame, you get the picture. And the point is, without these people, the autonomous cars we've been promised for so long wouldn't even be able to get out of the starting blocks. So AI needs people. Also, a human designs the network, a human trains the network, a human curates the outputs, a human applies makes the value judgments. So AI does not exist outside of humans. This was when the pandemic hit, we were told this was the moment that AI was going to come into its own, because it's going to identify who has COVID, it's going to identify clinical approaches, but as it says here, none of the 2,000 plus studies were of any clinical use. So AI had an opportunity to stand up here and it failed. Other problem, I think, and this is particularly important for me, is that we are increasingly reliant on the big companies. The big companies that have lots of money, a lot of them in California, but others as well, and over which we have zero democratic control. So for me, that's an increasing worry. You've probably heard of Jeffrey Hinton, worked for Google, made a fortune, retired from Google and said, oh my God, AI is going to take over the world, we need to panic. So this is the kind of thing he was talking about. Meanwhile, have you heard of this person, Timnit Gebru? She also worked for Google, but she was fired from Google because she criticized Google's ethical approach. And what she's talking about is not worrying about some distant future about what might or might not happen, but it's talking about what's happening today, the ways that AI is being used in ways that are actually quite destructive. So any idea how the AI system determined that the people on the left were okay and the people on the right were higher risk? Any guesses? I think it's pretty obvious. And this system has been studied multiple times. It's in use today across the US in different counties. Huge problem. So that's my quick whirlwind tour of the problems of AI, but we're here to talk about AI and education. So the first thing to note about AI and education is actually the connections are quite complex, as Ken was just saying. It's also a long history. But to think about this complexity, the first thing I like to do is think of it in two buckets. So my first bucket is teaching and learning with AI, and my second bucket, teaching and learning about AI. Now, these two things are quite distinct, but clearly they have overlaps. And we need to think about them both, in my opinion. So first of all, teaching and learning with AI. Now, this is normally what's referred to as AI Ed. As Ken said, the AI Ed community has been around 40 plus years. And there are, you might divide them further into student-focused AI Ed, teacher-focused AI Ed, and institution-focused AI Ed. So again, three overlapping areas, but useful for argumentation here. Here's institution-focused AI Ed. And this is from a paper we published about a week before ChatGPT appeared. So it didn't date us at all. But anyway, admissions, course planning, school security. Interesting, this actually has had less research, but I suspect this is going to be the bigger field in some ways. I think of it like the Californian gold rush, where it wasn't the people who were digging for gold who became rich. It was the people who were setting up the bars and selling the jeans and selling the food. And I think this might have that feeling. But that's institution-focused. This is student-focused. So these are all different types, different ways in which AI has been applied in education context to support students directly. The one at the top there, intelligent tutoring systems, what Ken referred to. We'll come back to that. But look, in the middle, we did actually predict this in a way. We called it automatic writing. So a lot of different stuff there. I'm going to talk about just one, the ITSs. And why I think this is important is because that list on the right are the multi-million-dollar funded companies around the world that have developed these systems based on research, and they're using it in lots of school districts and schools today. But they're companies, they're corporations. Going on to teacher-focused AI Ed, and with these are mostly speculative, because most of what we've seen so far with the student-focused AI Ed is that their aim is to automate teacher functions. So a human tutor, instead of having a human doing it, why can't we get an AI Ed system to do that tutoring? So we're automating teacher functions. With these, this is the ambition to do things that actually support teachers to do the work they do. I'll give you a couple of examples. So this one is automatic writing evaluation. It's using the system to actually understand what a student's doing. In the case of this one, to give formative feedback, but in some to actually do high-stakes assessment, which I find incredibly worrying. But this one is different because, and that previous one is perhaps not really supporting a teacher, but this one is, because in this one, the AI system does not do the assessment. It's the human teacher who does the assessment, but with the support of the AI system. So I think this is quite interesting. So that's a quick whirlwind tour of what it is, and you've heard lots about it today in different things. The point is it is complicated, and there are lots of different things. So I'm now going to try and burst the bubble a bit on this as well. So firstly, I want to make the point that education does not equate exactly to learning. They are not the same thing. And I find it quite amusing that the AI Ed community that's been AI in education for all its 40 plus years has mostly focused on learning and hasn't really thought about education more broadly. Ken will probably disagree with me, but we'll have that later on. But you can see here the different things. So qualification, this is a guy called Biesta. So the kind of learning skills, knowledge and skills, that's the stuff that all the AI Ed systems focus on. Whereas they don't talk about socialization at all. They don't really push that, and they don't push the individuation. And this is quite different to the personalization, which I'll come back to. Another thing we hear all the time is these systems are intelligent. I mean, to be fair, the word intelligent is right in the middle of the name. But they are not. There is no AI system today that deserves the word intelligent. The problem is that they can look intelligent. And as Ken was saying, you look at the output of ChatGPT, and it's amazing. It looks intelligent. But I think of it a bit more like this. So this is a machine that was touring the courts of Europe in the 18th century. So that's a machine, kind of a primitive robot, and it played chess. So you can come up and you can play chess. So this looks pretty intelligent, right? But this is the reality. Inside the box was a little man who could play chess, and so it was a human playing chess, not the system. Another thing we hear all the time is that these systems are designed to save teacher time. Now, this has emerged from back in the 1930s when Skinner developed his first teaching machine, and that was his ambition, to save teacher time. That was one of them. But it doesn't really save teacher time. It does displace teacher time. Instead of doing that, they do this, but they don't get any time back. But if they do save teacher time, then what about this? Has reportedly replaced educators. This is this year. This is a couple of months ago. So the suggestion that it's not going to happen, I think we need to pay attention, because it is happening. Personalization, we've heard that many times today. I think it's a ludicrous thing, because we don't actually use these systems to personalize. We personalize the pathways, the routes to the same fixed learning as everyone else. So it's not real personalization. We need to think about these things much more carefully. We need to think about collaboration and the social impact. Ken did show us a video where children were working together. That's what we need, and there's very little of that. We need more of that. But also these tools tend to disempower teachers. They take the decision-making away from teachers, so teachers are left with switching on the machine and making sure it works and making sure there's behavior in class, like that example from Austin. Also, there's possibly an impact on the children's cognition, and we don't know. There's evidence that people who use sat-nav to navigate their way around towns actually negatively impacts on their cognition, but we just don't know about the impact of these tools on the children and what they're doing. Also, some of the tools claim to be able to detect the emotion of the children. Good logic. If they're in a bad emotional state, if we can detect it, we can get them into a good emotional state, enhances the learning. But for me, that's kind of like crossing a final privacy frontier. Or at least it would if they work, which they don't, of course. We also have things like this. Again, this is from China, the picture. But before you get all angry at China, the technology being used here was actually developed here in the US. And it's being used elsewhere, such as knee proctoring. One of the key things is that these tools, if they're not careful, they do influence the human rights of the students concerned. So these different things, the human right to dignity, to autonomy, to be heard, to not suffer from discrimination, to privacy, and to be protected from economic exploitation. Every commercial AI tool extracts the data from the classroom, from what the students have done, and uses that data to build their business models. Well, if that's not commercial exploitation, I don't know what is, but that's what's happening today in schools across the US and across the world. And this is another example where we're using a technology to address a task which really we need to address using social means. So this is from the UK. The school introduced face recognition so that the students didn't have to queue to pay for their food. Well, the social way of dealing with that is stop charging the children for their food. I didn't have to pay for my food when I was at school. Ken and I have had this discussion before. He quotes the 2014 study, which compared an ITS and other stuff with business as usual. Well, that really, in my opinion, doesn't tell us a great deal. And I would argue that today, even today, we have very little, if no, independent studies at scale to address the efficacy, the safety, or the impact on the classroom of these tools. These studies just haven't been done. So that was my with, this is my about, and this can be divided into the human dimension and the technology dimension. And looking at this, I use this metaphor. If you're going to drive a car, you need to know that it needs gas, right? You need to know perhaps something about the engine. You need to know about the safety. We all agree with the safety, right? But with the AI, what happens? Well, just as we need to know how these things vaguely work and where they might be used, I suggest we need this for all of our students. Whether they're interested in technology or the arts, doesn't matter. They need to be aware of this stuff. Some students might want to learn how to do this stuff, how it works, and so getting students to actually engage in doing coding, etc., that's all fine. And those students who wish to go on to be engineers, they need higher stuff, but everybody probably needs some kind of understanding. But I would argue every single student needs to have some understanding of the safety and the human impact. And this is not taught. The vast majority of courses about AI today focus 95% on the technology, and the last 5 minutes they would do ethics, and that means bias. That's all they do. We need far more than that. And this is a way of looking at it. The technology dimension, the human dimension, actually intertwining those in our teaching, so that if we talk about facial recognition, we should talk about the technology, but also the impact on people, like that young woman who was changed. I'm going to finish by talking about Gen AI because it's obviously a big popular topic at the moment. So you all know this. You all know that there are many different things, and many of you have probably seen this. And the reason I keep this in here is because this, for me, illustrates one of the strange things about this that people don't talk about enough. To create this picture, it took the human person days upon days upon days writing prompt upon prompt upon prompt. And then everybody says that AI generated this picture. Well, no, the AI did not generate the picture. I mean, it did, but it was only based on what the human had spent hours upon hours upon hours doing. So this separation saying this is AI generated, not human generated, I think it's quite an issue that we need to be thinking carefully about. Now, the reality is if you spend just 10 minutes on the internet, you're going to find thousands of different websites that are telling all the marvelous ways in which AI can be used in educational contexts. But this is what I like to think of generative AI. I think this is a way of thinking about it, and if we bear this in mind, then we're going to be using it more effectively. So firstly, ChatGPT, it looks human-like, but it isn't. It looks accurate, but as we've heard, it isn't. It looks intelligent, but it really isn't. And it looks like it understands, but I guarantee it does not. We need to think about this when we're teaching our young people about how these systems work and how we can make best effect of them. If you're a teacher and you're thinking about using it, you need to have this simple equation in mind. Are you interested in accuracy or are you interested in speed? So as a teacher, if all you care about is the speed of getting your stuff done, then fine, use ChatGPT or similar. But if you're actually interested in doing something of high quality, I think twice. Be very, very careful. This, for me, represents the complexity of the world in which we live. The world in which we live is amazing. It is so diverse. All the people in this room, you're all different individuals, and it's just this room. So what happens when ChatGPT works? Well, ChatGPT does, it takes all this amazing complexity and difference and individuality, and it turns it into this. It averages it out. It just reproduces the really standard things that everyone agrees on. And anything that's a little bit off center, anything that's not standard, gets thrown out. And that's particularly important if you're from a marginalized community. Last week, I was in the country Georgia. They have a unique language there that's older than any other, one of the oldest languages in the world, and they're still using it today. But I guarantee unless something happens, their language is going to get smaller and smaller and smaller because it's not part of the standard way in which ChatGPT and others work. The other problem is that this stuff was launched without any efficacy studies at all. They didn't care. They just got them out there. And all the dangerous stuff that we've heard about since just happened. Imagine if a car manufacturer did this. They'd be in prison. So why do we allow it when we're talking about AI? And this comes back to those Kenyan workers that I mentioned earlier. Not only are they doing this really boring work, but they're being paid $2 an hour for doing so. And they're identifying, so during the development of ChatGPT in particular, they were looking at all the stuff that ChatGPT was generating that was pretty disgusting, pretty harmful, pretty obnoxious. And lots of these people, they had marriage breakdowns, they had mental health problems, all sorts of things. But it's only because of the work they've done do we get to use ChatGPT. So when we think about the ethics, let's think about these people too. So, in conclusion, my argument is that the work that my colleagues and friends, such as Ken and Ryan Baker you heard earlier, and others have done in this field is amazing, right? What they've been doing over the past 40 years collectively has been really challenging stuff. But the problem is that a lot of what they've done still is problematic, in my opinion. It focuses on doing what teachers do. It undermines and disempowers some teachers. It undermines the agency of students. It includes lots of inaccurate things. It's problematic in lots of different ways. But also in many ways it misses out this really big opportunity in the background, the amazing things that could be possible. So instead of trying to develop tools that try and do what teachers do, and when those tools mostly can't do what teachers do, they could do tiny, tiny bits of what teachers do. Where's the evidence? Where's the research that we could have that focuses on supporting teachers to do what teachers wish to do? Think about the real problems that teachers have. We need more effort in that kind of space. So that's it from me, but thank you very much for listening. But rather than automating poor pedagogic practices, AI developers need to leverage AI's amazing capabilities to innovate teaching and learning without compromising pedagogy or human values, to empower students and learners, to support inclusion and equity, and for the common good rather than the commercial bottom dollar. So that's it for me. Thank you very much.
Thank you, Wayne. You're on.
Okay. John just questioned why I'm here. So, because of my appointment as a director of NSF AI Institute, recently I was put to the different, workshops, which I'm outliers, I would say, because I have background in engineering, but not in the education. So that being said, I'm now trying to argue about how the AI going to use in the education rather than give you some examples about how going to use these things for the education in the computer education practice. It's one example for the Verilog. I'll show you what is Verilog later on. To give a brief introduction about the NSF AI Institute, National Science Foundation of the United States, founded about currently 25 national AI institutes for the different topics. basically cover all the disciplines of National Science Foundation. So from agriculture, education, IT computing, which just mentioned it, so on the first. And actually the two biggest sectors of AI Institute are the agriculture and education, which is jointly funded by NSF and the Department of Education. So just for the information. So each of the institutes receive $20 million for 5 years, so yearly across multiple campuses on the different research topic. Okay, so this is one example of show, the scaling up of the ChatGPT models, over the years. We start, it's hard for me to see this, but anyway. So, the first ChatGPT tool started about 2018. Actually, it had been there for a while. The reason you may not have heard about this because the capacity of this model is so small, so they're not be able to offer anything meaningful until somewhere about 2022. So you start to look at ChatGPT 3.5. That's maybe the most successful tool you use, and after that we have ChatGPT 4, which have a much larger size and also capabilities. So that being said, we're trying to trace, the size of the models and also the size of the data we're trying to learn, to offer these capabilities. So this is the latest upgrade of the ChatGPT. You can find out we have a GPT-4 Turbo and also the Vision. So they basically offer the much longer sequence we're able to process with the different capability. We can convert, the different modalities for them from image to video or from the language or so on the first. And also, they dramatically reduce the cost of using these models. This will actually give us the good opportunity. You can actually embed those things into the tools of your AI education. Okay, so the future of the large language model application will pretty much like the one on the right. So we're gonna have the large language model that will serve as a foundation for many, many applications, not just for education. Basically for the ultimate goal is trying to use a large language model to replace a cognitive agent, like a human being, in many applications. It's just one of them, but you can actually identify many other applications. Education is just very small sector of this, our applications. So it's not new, actually. How people look at this, how people are going to use this AI model also for the education. Very recent publication talk about on the Nature, they talk about that ChatGPT has entered the classroom. I suggest you to read the paper. They talk about 7 topics, starting from the creativity, the time efficiency, all kind of stuff. So there has been well studied in the society about whether we're going to use those things or how they're going to impact the practice of the education. And the funny part is actually they, even ChatGPT can do not very well. For the example that you might identify like a math or something first, it's actually done very well in some application like a programming. It's not just because the ChatGPT is actually created by the computer scientists like me. It's just because actually it's a very unique nature of this model to process the language like our application. That's why if you start to adopt this ChatGPT in the practice of the education of programming. So that's why I want to use this test case to show you how fast this AI models evolve and how this quick evolution impact the practice of our education. So one example is actually talk about the large language model for the Verilog programming. It's, you may be familiar with some other languages like the Python, the C, or something like this. But the Verilog is actually the program, the language which we use to describe the hardware design. So if you have the background in the electrical engineering, we need to design the circuit by using the different, logical gate, like the AND gate, NOR gate, so on and so forth. Basically, they can be the little binary logic to really, build out the very complex logic, which can build like the computer, so on and so forth, which you're using. So recently, all these big companies, they start to support, the Verilog programming using OpenAI. It's a little bit more than just a traditional software, programming language, because to program the Verilog language, you need to know not just the programming knowledge, but also the knowledge about hardware design. So it's basically a very good example to show you need to have a domain-specific knowledge to use the programming capability of these AI models. So what is a Verilog? So Verilog is a standard programming language like a Python, Java, so on and forth, but it's actually used to describe the hardwares. So let's say you want to design the multipliers. You actually have a very complex, the circuit like we show here. Have a lot of multipliers. You need to map the matrix to the vectors or some forth into this layout and try to compute the output. You need to control the data flow, between different circuit or the component. You need to control the timing, the complexity, all kind of stuff. And define the input and the output, all those things we need to teach our students to understand, and not just the interface, but also anything underlying this. So one example is actually hard task is a matrix multiplication. You have a two matrix. You want to compute them as A times B equal to C. So what you can do, you have two vectors. You do the element-wise multiplication, add them together, get the output. And this is something you need to design. And it's not just because you can write the description saying, oh, A times B equal to C. You actually need to design the circuit which will guide all the signals within these modules. And so these two signals will send this to these multipliers, and the multiplier is going to generate the output. And then all the output need to be summed together to generate the output. So that's actually very complex data flow you need to deal with. Let's start with last year, 2022 March. That was the GPT-3 or something like. So when we say, hey, let's say trying to generate multipliers. So they actually give us something like we show here. It's basically have some modules called the multipliers, A, B, C, D, give some parameters, which is the dimension of the matrix, and give it the input and output. And they have some floating point to multiply all operations, add something, they give the output. It's basically our garbage. It's not going to give you any information. It's just very high level description about what it's trying to do. When we look at this, okay, sorry, it's probably not GPT going to be used, for our education or the teaching practice for this hardware design. So it's the first impression we had back to almost 2 years ago. Okay, remember the date, 2022 March. A year later, we retried it again. We say, oh, they now released a ChatGPT 3.5. Let's see what we will have. This is the model mostly common referred to the ChatGPT. When we talk about ChatGPT, actually the name was introduced when we have GPT 3.5. And the output follow a more detailed logical flow, but but it contains many errors as well here. But it's pretty much like what we are looking for. They have the input, output, they have a data flow in the description, they have the comments even, to show to our students, this is going to be something we are expecting you to write. Okay, so starting from then, we say maybe what we should do is we should start to develop the tool in our classroom to teach our students, they can interact with the GPT 3.5, to produce the Verilog code for these multipliers, and in our digital electronic design course. I will show here, even a lot of errors, fine. We just ask our students, to correct those errors and run those codes to see what we will get. So we started developing the tool for our a classroom back to March this year, but guess what happened? November, they released GPT-4 Turbo. So that's the latest generation model of the OpenAI. This actually can give very precise description of the code, just to give the code saying, let's write a multiplier, so A times B equal to C. They give pretty much a very accurate descriptions and also behaviors of the code that we show here. It's pretty much runnable. It basically means we spend 6 months efforts in our groups. Actually we end up with not even be able to catch the performance of the ChatGPT-4 gave to us. So the tool evolves so quickly so that we don't need to do anything. We just wait until the tool evolve and give us the correct answer. But even more than that, it's not just because we can use this tool to teach our students. Instead, give us another thinking about this. We probably don't need to teach our students because the tool can do the job our students are supposed to do, right? It is true. Okay, even more than that, we find out, the GPT-4, they actually have a version called a vision, if you still remember. you can just throw, the logical diagram like we show here, basically describe, the logical behavior of those components with we call state machine. So if you satisfy some conditions, the state will transfer from one to another. And if you just throw this picture, to the tool will be able to write the Verilog code, to describe the circuit, which can run the exact behavior of the figure is trying to do. It's what? It's actually what we're trying to teach to our student, right? We give them, problems in the exam saying, can you really write, the circuit for this, the logical diagram? Yes, they're actually still gonna write this code, but now say the two can do the same thing, only in 20 months, okay? So here are our observations. Number one, so over the course of the roughly a year and a half, the Verilog capability of the large language model has gone from the practically nothing to be very strong and will likely continue to improve. It will. And the tools are incredibly powerful for learners and practitioners and able to generate, debug, and explain the Verilog code, and make a powerful tool for both industrial practice and education, only in 20 months. And the barrier to entry for high-level design language, the HDL, basically the circuit design, will likely lower dramatically, and the practitioners are likely to be more efficient. And actually, there's one paper very recently talk about this. Actually, they show that they can improve the human efficiency by 65% by just adopting these tools in their practice. Okay, so we also look at how this the tool is going to impact our students in terms of the jobs so on the first. So there's actually another paper I suggest to read. Actually also a joint paper between some university and also Google. Talk about how many percentage of workers will be impacted, and they basically say at least 80% will be impacted by ChatGPT or let's say involvement with at least 10% of their task, and about 20%, actually 18% of the workers are in the occupation where over half of the task will be impacted. Okay, so and the difference between this technology revolution and the previous one we have a year experience in the 18th century and so on. First is those jobs are actually the high-paid jobs. They require the higher education, the years, the education or the skills, also on the first, and those jobs will be replaced first, and the impact the higher wage, that we saw on the first. It's very different from the technology evolutions we have ever experienced before. Okay, those are the truths. Okay, so those are takeaways I'll try to say here. So number one, the ChatGPT or basically the large language model will play an increasingly significant role in the computer education. Sorry, I can only say it's computer education. I don't really know much about others. And will be adopted more quickly than previously we had thought. And also, these tools will continue to evolve at a pace of far exceeding that of human beings. So we actually have a competition between the silicon brain and the organic brain, seriously. And significantly enhancing the productivity of the computer engineers. And the entry barrier for the computer engineering jobs is expecting to lower. Is it good news or bad news? Can you guess? It's hard to say, actually, because the demand for the entry-level computer engineers may decrease, and you have to be, for the human being, you have to be an entry-level engineer before you become an experienced engineer, right? But if we don't need so many entry-level engineers, who's going to become the experienced engineer? So the question is, what should we teach our college students in light of this development? And remember, we're competing with the evolution of these tools. They are not going to stop there and waiting for us. They will continue evolving. And they will kill many, many jobs, especially the entry-level jobs. And what should we teach our students? I don't know. So this actually the huge, the challenges we're facing now in the computer education. I believe we maybe quite quickly this concern will spread to some other sectors. I will stop here, and maybe you can go to the Q&A. Thank you.
Great, thank you. Okay, we have time for questions. If anyone has a question, if you'd line up by the microphone. I want to start by taking a little umbrage about something that one of Wayne's slides. He said, it looks intelligent, but it's not. It looks like it understands, but it's not. That's exactly what my wife said the other day. Did you get that from my wife? So we had three really big, important presentations. Do we know if Ken's coming back? Great, thank you.
I'm here.
Thank you, Ken. I'll give you the 5-line ChatGPT summary. I just threw all these presentations in, and here's my takeaway. So the summary from Ken was, be careful, but make sure to build on all the experience that we have in the world already with these kind of systems. My summary for Wayne is, whatever you do, think about the big picture and question the assumptions. And my summary for Urine is, the world is changing quickly, not only in education, but in what education is trying to do in the world. And we need to keep track of both those sides all at once. Sorry for the dramatic loss of information, but that's what we got. Let's have your question. I can't read your name tag, I'm sorry.
I'm Catherine.
All right, Catherine.
There seems to be a dichotomy amongst your presentations. One is, it's not smart, it can't do anything, it just has a lot of hallucinations. And the other one is, it's about to take all of our jobs. And so I wonder if you guys could, I guess, more actively discuss the fear with, it's going to take all of our jobs, it's so competent, can do all these things, with, it's completely incompetent and can't do anything, really.
Yeah, I mean, yeah, that is part of the contradiction within it all. I completely agree. The problem is that in education, the people who are in charge, the policymakers, the people who run school districts and even run schools, they have pressures on them to do things like save money. And one of the ways in which they can save money is by getting rid of teachers, as that school from Austin I showed you. But it's a very incredibly short-sighted approach. And, the tools really cannot do what they're all cracked up to do. For use for...
That's just not right, Wayne. You can't cherry pick your examples. Yeah. Like, there's tons of research out there. You didn't cite any of it. A lack of evidence isn't an evidence of lack, especially when you didn't cite any of it.
Okay. I acknowledge that the community was 40 years plus, as you did, and I acknowledge that they've done lots of studies. What I disagree with is that citing one 2014 study that compared the use of one of these tools plus a lot of other things against business as usual tells us anything at scale about whether these tools are efficacious, safe, and their impact on the classroom. That's the point I make.
What it tells us is that,
Ken,
yeah, I totally agree with you.
Ken, may I finish? I think it's important that we don't interrupt each other, otherwise it's going to turn into a fist fight.
He cannot see you, that's why. So,
yeah. It won't, I can guarantee you that.
Just so you know, Ken and I put a paper together fairly recently, so this is an ongoing conversation that we've had. So as I'm quite happy to say very clearly that there is almost no independent evidence at scale for the efficacy, safety, or impact of these schools on the classroom ecosystem. That's a statement of fact. There simply isn't. There are thousands of small studies. There are thousands of small studies that show an awful lot of positive things in different settings. I agree. I'm not questioning that. But what I'm saying is that we need to be really careful, because it's not just about learning. It's not just about we do a test, we give the students some access to some tool, and we do another test, and did they do better in the second test? That's really minor. Now, I'm not saying that the work in the community has not been really profound over the past 40 years. I agree it is, without any question. What I'm saying is my worry is that that trajectory, that direction, has been the wrong direction. What we should be doing is not trying to do what teachers do, but we should be using these amazing technologies to help teachers do what they really want to do. And I think that, we've heard little bits of that today, but that's not been the vast majority of the past 40 years of research. So I think we need to be really careful before we make big claims about what these tools can do without really good, robust evidence.
Okay, Ken?
Here's why that study is valuable, and I'll try to be briefer. It's because the answer isn't AI. The answer is an interdisciplinary combination of teachers, maybe text materials, certainly online materials of other kinds, professional development. If the goal is to prove that, medicine works, it'll never succeed, right? It's not about the technology. It's about the integration of appropriate uses of the technology. And that is what that study showed. And that's what we have to strive for. So we're totally in agreement that AI by itself is not solving any problems.
Yurin, did you want to say something? Thank you, Ken.
I'll just be very quick. So all the examples, presented by ones, I don't worry about too much because we really understand why. Okay, I never, as a computer scientist, I never worry about anything. I know it, I understand it, and I know the solution to solve it. Okay, that's number one. Number two, tool. There's no perfect tool. Okay, it's all about how people are going to use it. Rather than you worry about, we have a perfect tool or not, you maybe just worry about how can you use it, which means the policy making. So there is an association called the AAAIP, which is Academia Alliance, for AI policy, basically organized by Syracuse University, but many other universities join us, talk about how we can make the voice, to influence the AI policy in the Congress on first. I really suggest people to look at, what they're doing there.
I just want to make, thank you very much. I just want to make a comment, Katie. I think the other thing we need to think a lot about is what the tools are good at and what their behaviors are and what all our behaviors and goals are in education, which are many and vast. And so Yurin showed examples of where the tools are really good because those are areas where there's a lot of data and the task is very predictable. The outcome is very predictable. Human emotions are very unpredictable. Human history is very unpredictable. So I actually hope that these kind of dialogues lead to, when you make software, it's educational software, it embodies, and I think this is part of what Wayne is saying, and Ken is saying, it embodies your theory of what educational interaction should be, and hopefully some of these discussions help us unpack some of those assumptions we have. But one of those things in these systems that will do so many different kinds of things, it'll be good here, it'll be bad there, and then how we interact with it. So super complex, high-dimensional stuff going on. Thanks for the great question. Again, I can't see. I need binoculars. Allison, did you bring the binoculars? Yeah. I used to be able to see.
Yes.
Okay, thank you.
Nice to meet you. Nice talk. So my question relates to the purpose and value for language learning, given that AI is so good at translating and it will probably get better. So I'm an international student from China, and I spent 10 years in US. Before I came here, I need to learn English, of course. And so my question is, in the future, does students still need to acquire a different language if they want to study abroad? Also, how do you think this will change the human-to-human connection? Like, for example, if I want to go to a country that doesn't speak English or Chinese, do you think this AI will change the dynamics between the travel and education export?
Thank you.
Yeah.
That's an easy one. Who wants to take it? Yurin's going for it.
I'm not quite sure it's either one, actually. It's actually more complicated than you thought. So if you look at, the countries, who were on the open list in the first round of the OpenAI, to China and many other countries were not there. It's not because of political reasons, because the data from those countries are not trustable. Okay, so if you look at the data provided by the simplified and Chinese or on the first, the data are not trustable and data are highly biased. It's actually going to impact the performance of the models. That's why they did not open up the service to those things. Go back to your question. we have very good translation tools to translate the language back and forth. I don't think that's the issue. The issue really is the information provided in the different languages are sharing the similar, I would say, trustworthiness or not. I think those are the biggest challenges behind this. I don't think we have a solution yet.
Wayne, any comments?
I've been very fortunate this year, and I've traveled to a lot of different countries, and in all of them I don't speak the language. So coming here was great because I actually do speak this language. And the technology I've been using to help me in those countries is amazing. I'm not questioning that at all. And it does help me communicate, it helps me read signs and all the other stuff. But if it did lead to the situation you're suggesting where we don't need to learn another language, we can just have an earpod and we just speak in our own language and it automatically translates to the other person's language, and that would be amazing. Of course it would be amazing, and I look forward to seeing that in action. But if it went too far, if it undermined the humanity of being human, what's fascinating is the fact that we speak between us hundreds of different languages, and that speaks to our humanity and the differences between us, as well as the similarities. So I'm not very good at predicting, but I hope that it doesn't stop us learning other languages. Just as an aside note, and our colleague was online, so it's not fair, but I've been using Duolingo. I have a streak of 1,382 days to learn French. Thank you very much. I cannot speak French. I go to France regularly. And I walk into a hotel, I get into a taxi, and I speak beautiful French. And they have the temerity to reply to me, and I don't understand a word they're saying. So, I started using it because I thought I should actually get together with the technology. But, yeah, I'm going to keep using it, and we'll see.
Thank you. Ken, do you have any comments about that question? Okay, we're going to go to Kirk Becker.
All right, thank you. I will suggest you all take a look at the effect that Duolingo offering a language has on languages that are endangered, but that's not my main point. A couple decades ago, a guy named Larry Butler put together an algorithmically informed way of suggesting therapy options. The difference between medication or psychotherapy or group therapy, et cetera, finding that it was way more effective than just a kind of a one-size-fits-all. And as you can imagine, there was a lot of resistance within the psychotherapy and other therapy divisions to this. So when, thinking about a situation where a technology can improve upon the teaching practice, are we you mentioned a number of issues around the kind of the corporatization of decisions around educational policy, but where I'm suggesting that some of the resistance to some of these may come from classroom teachers who actually could be benefiting from this. And so what sorts of things can we do to identify and address those kinds of concerns?
Let's give this one to Ken since we kind of dropped him off on the last one. Ken, any thoughts?
Sorry, having trouble getting off of mute. Yeah, well, empowering teachers and dealing with the tricky issues of adoptions of new approaches and technologies. Those are both great challenges. That smart glasses thing, project I mentioned, involved months of user-driven stakeholder design where Ken Holstein, the PhD student who did that work, was working with teachers and asking questions like, if you had superpowers, what would they be? And the idea to use the smart glasses rather than have the dashboard information on a handheld came from the teachers. Well, in the sense that they wanted to have their hands free and their eyes up, not their eyes down, holding on to something. But I do think that, we're going to face, we do face adoption challenge. We know forever that learning by doing and active learning approaches are super effective, but we still have mostly sage on the stage rather than guide on the side. And I think that's fundamentally because we don't understand ourselves, and we think we do. We don't have enough science of ourselves to help us better understand, for example, the power of active learning and how these technologies can support it. So I think that's we have to keep working in the field to work with educators to make improvements, but at the same time, I think we have to also do a better job of teaching the science of ourselves in K-12 schools.
Great. I'm going to call time on that. We have one more question. If you could talk to the panelists during the break. We'll have a break now. I just want to thank everyone for the participation and for the questions, and let's give our wonderful, insightful panel a hand.